So yeah, we are going to be looking at trigonometry ratio, and under this trigonometry ratio, majorly we are going to be looking at what we know as SOHCAHTOA. So based on the definition, it's this one is SOH. SOHCAHTOA. We have this to be sine of theta, which is equal to opposite and hypotenuse. Opposite over hypotenuse. Then we have CA, which is cos of theta, which results to A, stands for adjacent, and H is hypotenuse. Likewise, we have for that tan, which we are looking for tan of theta, which is equal to O, which is opposite, over adjacent. So this is the basic formula for SOHCAHTOA, just like what we have here. Looking at this material here, we have sin theta, which is equal to y over r, whereas this y and r have already been labeled in what we have on this part here, where r is the longest side as it is facing the right angle triangle, and x is the adjacent, likewise y is the opposite. So but before we can use any of this, we should first make sure that we are working on a right angle triangle. A right angle triangle is a triangle that has a straight line and another line, a straight line, and another one that connects the two edge. So with this sharp angle here, and the angle that is facing this angle, the side that is facing this angle is known as the hypotenuse, whereas the side facing wherever the degree is or angle is what we call the opposite, and the other part is known as the adjacent. So the hypotenuse is known to be the longest side in this right angle triangle. So to find the side, that is to find the length of that hypotenuse, we have a simple formula for it, which means hypotenuse square will result to opposite square plus adjacent square. So this also means that when we are looking for any other side other than the hypotenuse, what we just do is to collect subject of formula by saying, let's say for instance, we are looking for the adjacent. It's going to be adjacent square is going to equals hypotenuse. Hypotenuse is the longest side, so we put it first. Hypotenuse square minus opposite square. The reason being that whenever we try to collect like terms, let's say for instance this opposite, it moves to this other side here, the sign changed to minus, so hypotenuse minus opposite, that's what we have there. Likewise, if you are looking for opposite, it's going to be opposite is equal to hypotenuse minus adjacent. So this is the basic formula for finding the length of each side in a right angle triangle. So let's look at a very simple example based on what we have here. As you can see, we have a simple example here. We have a right angle triangle that is facing the left hand side. So on this side we have 12, and on this side we have 5. And as you can see, this is the right angle here, which means angle 90, and it's facing this side. That is, this side is the hypotenuse. So this is the hypotenuse. To find the hypotenuse, we come back and use this formula here. So now let's go back to what we have by applying that formula. So what we are going to have now is we are going to be having hypotenuse square, which is what we are actually looking for, Let me type it up. So I say hypotenuse square is equal to, I don't know what hypotenuse is yet, is equal to opposite square plus adjacent square. So now, since we know the formula, then hypotenuse we tag it as x because we don't know what it is yet. So we say x square is equal to the opposite. We already know the opposite because this is the opposite facing the angle that we are actually looking for. So we say the opposite is equal to 12. Then we say 12 square plus, then the adjacent, which is what we have here, that is 5, then plus 5 square. So based on calculations, I still have x square, which is equal to 12 square results to 144. Then I say okay, plus 5 square results to 25. Then the solution to that will give me 144 plus 25 will give me 169. So having the answer, I still have to isolate x, which means this square is disturbing x that I have there. So what I just have to do is to square root both sides so that I can isolate the value of my x. So proceeding with that, I have x should now equate to the root of 169, which will result to the root of 169, which will result to 13, which is now the final answer to this. And as you can see, a simplified approach has been given here, where we just find the root of the answer, the summation of the answer directly, instead of having to follow through all of this process. So regardless, when you're looking for any side, you just have to follow this particular formula that is given here, this particular formula that we have here. So with this guide, I'm very certain that everything will be simplified. So having gotten that, we can also impute this. Since we already know the value of our x, we can impute this back into the triangle, and as you can see, it makes sense when we have 5 here and we have 12 here, and this longest side here is 13. So how it makes sense is that the longest side is the one that's supposed to have the highest value. So here we have 5 and 12, whereas 13 is the highest in this case. So that being said, to find um, whatever value let's say for instance sine theta, that is when we now have to work on what we have under our SOHCAHTOA, where we have to now look through the formula. That is what we have up here, where sine theta can be gotten by saying opposite over hypotenuse, cos theta can be gotten by saying adjacent over hypotenuse, and tan theta can be gotten by saying opposite over adjacent. So once you remember this SOHCAHTOA, it's just a way of you remembering the formula. That is when you are looking for a particular degree, and as you can see here, what we are actually looking for is theta based on this. So here we are asked to find sine theta. I don't know what this is, but using this formula I can easily get it. And sine theta says opposite over hypotenuse, so for me to get that, I already know that my hypotenuse is 13 based on what I have here. So I can say opposite sine theta can be given by saying opposite over hypotenuse, and my opposite is the same as 12. As you can see, the opposite angle facing the degree side, that is 12, over hypotenuse, which is the longest side that we just calculated, that gave us this result, which is 13. So I'll say sin theta is equal to 12 divided by 13. By punching it into my calculator, my result will surely come out. Let's say, for instance, I have a degree here just like 45, or I have about 60 or whatever. So to get a specific or special angle, we are going to look at how we can go about it. That one, we are only going to be dealing with equilateral triangle to get all of those formula. So let's look at all those special angles that we can actually come across. So those special angles, we can have special angles. We can have angle 45 degree. We can have that of 60 degree, and we can have that of 30 degree. So looking at this, like I said, it comes out of this equilateral triangle. So we say this is a big equilateral triangle. Here we assume that all sides are equal. So here, an equilateral triangle, the angle at each corner is equal to 60 degree. So we have 60 degree here, we have 60 degree here also, and we have 60 degree here also. So that will now equate to 180 degree in total. 180 degree. Having said that, using this triangle, we can now calculate for these special angles that I just mentioned now. So let's look at an example on how we can bring out the right angle triangle from this. So to do that, what I'll just do is to divide this equilateral triangle into two equal parts, and as you can see, I use the red ink here. So this here, since since as you can see, this, when it is now shared into two, I have a perfect angle 90 degree here and a perfect 90 degree here, which is depicting that this straight line here is 180 degree angle on a straight line. So since I have I shared it into two equal parts, I'm having 90 on the right hand side and I'm having 90 on the left hand side. So basically, when we have an equilateral triangle and we are trying to solve any of this, we always put the length to be 2 each on all sides. So I will just put that here. This side here is 2, this side is also 2, and this whole side is 2. But now that I've now shared it into two equal parts at this point, this side will be 1 and this side will be 1. So what I'm now left with is the length that I have on this side here. So to get that, we can look at these special angles that we have here, just like what I have just explained: 45, angle 30, or angle 60. So working with that, after I divided this part into two, what I can have after I divide this part into two, what I can name this is what? Root 3. So I'll just put that here using a black ink. So I'll say this side here is what? Root 3, which is the length of this side. So what I'll just do now is to cut this triangle into two. So I'll just have to bring out one. So here I have let me just switch the painting to blue. So here I just have one of the triangle, then on this side I have the 90-degree, just like I do here. And what I'll just do is here I still have my complete 60-degree, and here as you can see it was 60 initially, but when I divided this into two equal parts with this red line, it's now share this degree into two equal parts. So now I'll be having 30 on this side, so that is 30-degree. And as you can see here the length is still 2, so I put the 2 here, and the length of this from here to here is 1, and like I said it is shared among the two this thing. And here like I said, we are going to be having root of 3. So this is half of this equilateral triangle that I pull out. So to solve a question pertaining to this, let's say for instance asked to find the I'm asked to find sine, let's say sine 30. What I'll just do is to say, okay, sine 30 is equal to, I know that to find sine, when I have my SOHCAHTOA S stand for so, which is opposite over hypotenuse. Then what is the opposite here? Here I'm looking at what angle actually? I'm looking at angle 30. I'm working with angle 30. So what I will just do is, okay, what is the opposite of angle 30? Which is what I have here. That is what? 1. So I have 1 over, then here hypotenuse. What is the hypotenuse? Hypotenuse is the one that is facing the right angle, which is angle 90. So I have 2 there, which is 1 over 2. And if I should punch this inside my calculator also by saying sine 30 is equal to what, it will also give me 0.5 or 1 over 2. So this is how to find the ratio of any angle that we are given. But here, since it is being simplified, we are only working with special angles, which are 30, 45 and 60. Then this one should be straightforward. We don't need a calculator to solve this. But this only works for these two angles, that is angle 30 and angle 60 likewise. But when we are working with angle 45, like what we can see on this side, here this is where we are working with angle 45, based on what you can see. So here we are working with angle 45, and this is the right angle. So what I'll just do is to draw this out. This is the angle 45, this is the right angle 90, and this is also 45. So what just happened here is that all sides here are just 1, and the longest side here is what? Root 2. So if I'm to draw this out, I will be having something like this, where this is 90 and this is 45. So the longest side, which is the hypotenuse, is now what we name as root 2, and other sides are just 1 and 1. So if I'm asked based on this to find um, let's say sine 45, then what I will just do is, what is sine? It still means opposite over hypotenuse, and the opposite, this angle 45. So what is the opposite here? Which is what? 1 over, the hypotenuse is root 2. So when we are asked to find sine 45, the solution will surely be 1 over root 2. By the time I punch this into my calculator, it will give me the result that I expect to get from that. So to get the ratio of any of this angle, what we are going to use is sine, cos, tan. We also have others which are tangent and cosine and other, but the most simplified one are those three, which is sine, cos and tan. And we have looked at how we can work with it with these special angles 30, 45 and 60. And like I mentioned earlier, we can only work with 30 and 60 where we share this equilateral triangle into two equal parts, where the whole triangle have 2 on this side and have 2 on this side and have 2 on this side also. So that being said, sharing it into 2, we put that root 3 on this side. There is going to now be the opposite if you are working with angle 60, and it's going to be the adjacent if you are working with angle 30, just like what we have here. So in this now, if I am asked to find let's say for instance sine 60, so what I will just do is, okay, sine 60 will result to sine 60 will result to, now let's look at how we can solve that. We already know that to get sine 60, what we just have to do is opposite over hypotenuse. Now I'm working with angle 60. What is the opposite? The opposite of angle 60 is 30, root 3 here. So I say, okay, I have root 3 over, then the hypotenuse, which is the longest side, is what? 2. So here I have root 3 divided by 2. By the time I punch it into my calculator, it will give me the final results. Yeah, so there's no much problem in getting any value of a trigonometry. Like I said again, there's just a reminder, when you are looking for the length of any side, what to do is to say hypotenuse is equal to hypotenuse square is just equal to opposite square plus adjacent square. So if you need to do anything, like let's say for instance you are trying to look for the opposite, what you just need to do is to collect like times and apply that formula. So irrespective of whatever you're trying to do, this formula will give you the required solution. And yeah, this material already explain what you need to know on that. So let's look at a brief, like here when we are asked to find cos 45, and you know cos 45 is just going to be different, and here we have tan 60, and tan is what? 12, that is opposite over adjacent. Here what is the opposite of 60? Root 3, and the adjacent is 1. So that's how we have root 3 over 1, which is the same as root 3, just like we have on this side here. So that being said, I think that should answer your question on trigonometry.